October 21st, 2025. While you were scrolling through your feed, eating breakfast, or maybe sleeping on the other side of the world, something unprecedented happened. NASA activated its planetary defense network, not for an asteroid, not for a near-Earth object we've been tracking for years, for an interstellar visitor. For the first time in human history, the International Asteroid Warning Network, the same coordination system designed to save humanity from extinction-level impact, quietly powered up its global telescope array and pointed every available instrument at a single target. 3 Atlas, the comet that is not supposed to be here. You would think an event like this would dominate every news cycle, every headline, every conversation. But it did not happen with a press conference. There was no dramatic announcement. Instead, at exactly 21:101:08 Universal Time, a single PDF document appeared on the Minor Planet Center website. Bulletin 2025 U-142. 16 lines of text buried in technical jargon that most people will never read. An editorial notice announcing an astrometry campaign. Dry, clinical, forgettable, except for one detail that changes everything. The target is 3I Atlas, an interstellar object. And the organization running this campaign is IWN, the International Asteroid Warning Network, the planetary defense system. Now, before we go any further, I want to hear from you. Hit that like button, subscribe to the channel, and tell me in the comments where you are listening from, what time it is there. And honestly, does this whole thing feel like a cover story to you? Help our community grow by sharing this video and hitting that hype button below. Thank you for your support. Let me be very clear about what the International Asteroid Warning Network is, because this is not some academic study group. This is not a collection of enthusiasts with backyard telescopes. IAWN is the operational backbone of planetary defense. When an asteroid is discovered on a collision course with Earth, IWN is the entity that coordinates the global response. They synchronize observations across continents. They calculate impact probabilities. They advise governments. They are the people who would tell us if we need to evacuate cities or launch deflection missions. Their mandate is simple and terrifying. Find the threats, track the threats, give humanity enough warning to do something about it. They test their coordination on bodies that matter, potential hazards, anomalies, high-interest targets, not routine comets, not objects on safe trajectories, objects that could change everything. And now, for the first time ever, they have activated for an interstellar visitor. A visitor that, according to every official statement, poses zero threat to Earth. A visitor that will not come within 270 million kilometers of our planet. That is the part that should make you pause. That is the part that does not add up. The bulletin itself is a masterclass in understated language. It announces a comet astrometry campaign running from November the 27th, 2025 through January 27th, 2026. The stated purpose to introduce methods for improving astrometry from comet observations, to exercise the capability of the observing community to extract accurate astrometry. They're framing this as a training exercise, a workshop, an opportunity for astronomers to refine their measurement techniques on a challenging target. And the challenge, they explain, is that comet bodies are extended with morphological features, come in tails that can systematically pull their centered measurements off their central brightness peak. That sounds reasonable. That sounds scientific. That sounds like exactly the kind of technical problem astronomers love to solve, except for one glaring issue. 3 Atlas does not behave like the comets they are describing. Its phototrick center, the point where most of its light appears to originate, does not line up with its predicted orbital position. The light and the mass are offset. That is the anomaly they are admitting to in the fine print. That is the problem they are trying to solve, and it is a problem that has been discussed quietly in academic circles for months. An object where the brightness does not match the trajectory. An object that seems to be glowing from the wrong place. Now, think about the timeline they've laid out. The campaign does not start immediately. It starts November 27th. Why that date? Because 3 Atlas reaches perihelion, its closest approach to the sun, on October 29th. Then it spends the next month emerging from the sun's glare, moving back into observable range for Earth-based telescopes. The in-observation window opens exactly when the object becomes visible again after its solar conjunction. After it has been hidden behind the sun for weeks, after it has passed through the one region of space where we cannot watch it. The schedule is precise. Workshop on November 10th. Kickoff meeting November 25th. Observing window opens November 27th. Mid-campaign check in December 9th. Window closes January 27th. Closeout telecon February 3rd. This is not how you organize a casual training exercise. This is how you coordinate a multinational surveillance operation. This is how you make sure every major observatory on the planet is watching the same object at the same time, collecting the same kind of data, feeding it into the same analysis pipeline. And here is what makes it even more interesting. The workshop on November 10th requires registration. Only participants who attend the workshop can join the campaign. That means they are vetting the observers. They're making sure everyone involved understands the protocols, the data formats, the reporting requirements. They're creating a controlled group of vetted astronomers who will all be looking at 3FE Attalus during its closest approach to Earth in December. Registration closed November 7th. That was 2 weeks ago. The list of participants is not public. We do not know which observatories are involved. We do not know which telescopes will be retasked for this campaign. We do not know what specific instruments they will use or what kind of data they are prioritizing. All we know is that by the time 3ELS makes its closest approach to Earth on December 19th, the entire planetary defense network will be watching silently, systematically, without fanfare. Let us talk about what astrometry actually means in this context, because the word gets thrown around a lot and most people do not realize how crucial it is. Astrometry is the precise measurement of an object's position and motion. For an asteroid or comet, good astrometry tells you exactly where it is, where it has been, and most importantly, where it is going. It lets you calculate the orbit with enough precision to predict close approaches years or decades in advance. It lets you determine if an object will hit Earth or miss by a safe margin. It is the foundation of planetary defense. When they say they're improving astrometry for 3 for Atlas, what they are really saying is that the current measurements are not good enough. The orbit is not as certain as they want it to be. The predictions have too much uncertainty, and for an object that poses no threat, that should not matter. You do not need millimeter precision on the trajectory of a comet that will pass us at nearly twice the Earth's own distance, unless you're worried it might not pass us, unless you're worried the orbit might change. Unless you're watching for something that could alter its trajectory during perihelion, the Earth effect. That is the term that keeps coming up in the technical discussions. It is a principle from astronautics that says the most efficient place to change a spacecraft's trajectory is at the point of highest velocity at perihelion, when the object is moving fastest and the gravitational potential is maximized. A small thrust applied at perihelion can produce a massive change in the final orbit. If you wanted to slow down from interstellar speeds and enter a bound orbit around the Sun, perihelion is where you would do it. And for 3 via Atlas, perihelion happens on October 29th, 8 days after solar conjunction, 8 days after it disappears behind the Sun from Earth's perspective, 8 days of optimal maneuvering time while hidden from view. Now, I'm not saying 38 LS is performing an Earth maneuver. I'm saying NASA is organizing a 2-month surveillance campaign that starts exactly when we would be able to detect the aftermath of such a maneuver. I am saying they are coordinating the planetary defense network to watch for trajectory changes, outgassing anomalies or fragmentation events that could indicate something other than natural cometry activity. I'm saying the timing is too precise to be coincidental, and they are not hiding this. The bulletin is public. Anyone can read it, but it is written in the language of bureaucracy and technical protocols, designed to be boring, designed to be skipped over by anyone who is not deeply embedded in the field. It is transparency as camouflage, hiding in plain sight by being too tedious to pass. There's another detail in the bulletin that deserves attention. They mention that cometry bodies present unique challenges for accurate astrometric measurements. True. But they also note that 3EA Atlas is being used to exercise the capability of the observing community. That word capability is interesting. Not accuracy, not precision. Capability. the ability to do something, the capacity to coordinate a global observation campaign on short notice, the readiness to track a fast-moving interstellar object as it transitions through different regions of the sky. This is a drill, but it is a drill using a live target. It is practice for the day when we spot an interstellar object that actually does pose a threat, or it is a response to an object that has already triggered every internal alarm, and they are using the language of a drill to keep the public calm while they figure out what they're dealing with. Consider what happened with the Mars flyby. On October 3rd, 3 Atlas passed within 30 million kilometers of Mars. Multiple spacecraft were positioned to observe it. The Mars Reconnaissance Orbiter with its high-rises camera capable of resolving features down to 30 km per pixel. The ExoMars Traceus Orbiter with its Cassis imaging system, Mars Express with its HRSC camera and Omega spectrometer, NASA's rovers on the surface. Perseverance and Curiosity pointing their cameras at the Martian sky. The European Space Agency released a handful of images from the flyby. Fuzzy, distant, the comet appeared as a slightly blurry white dot against street stars. Exactly what you would expect from a fast-moving object at that distance. But NASA has released nothing. No high-rise images, no spectroscopic data, no press release celebrating this unique opportunity to observe an interstellar visitor from multiple vantage points simultaneously. The silence is conspicuous. High is one of the most powerful cameras ever sent to another planet. It can resolve details smaller than a dining room table from orbit. At 30 million kilometers, it should have captured the best images of 3 Y80-less we have ever seen. Images that would reveal the size of the nucleus, the structure of the coma, any jets or outgassing patterns. Images that would answer basic questions about what this object actually is. And those images exist. They were taken. The data was transmitted back to Earth, but it has not been released, not to the scientific community, not to the public, not even as a preliminary data set. There are two possibilities. Either the images show nothing unusual, and NASA simply has not gotten around to processing and releasing them, which would be bizarre given the level of public interest. All the images show something that requires careful analysis and coordination before any public statement. Something anomalous, something that changes the assessment of what 3 Iatelus might be. And now, less than 3 weeks after that, Mars flyby Activé, activates. The Planetary Defense Network spins up. The global astrometry campaign gets announced with workshop requirements and closed registration and a 2-month observation window timed precisely to the object's closest Earth approach. You do not do that for a routine comet. You do not do that for an interstellar visitor that poses no threat. You do that when you need every telescope on the planet watching the same object, collecting the same data, ready to respond if something changes. You do that when you're tracking something that might not follow the expected trajectory. You do that when you're preparing for contingencies that you're not yet ready to discuss publicly. The document ends with a simple, bureaucratic sign-off. MPC staff, copyright 2025, MPC, no dramatics, no implications, just another day at the Minor Planet Center. Just another editorial notice in an endless series of bulletins about asteroids and comets and orbital mechanics. Except, this one is different. This one activates a network that has never been activated for an interstellar object. This one coordinates a campaign on an object that officially poses zero threat. This one times its observation window to coincide with the exact period when we would be able to detect any deviation from a purely gravitational trajectory. 3. I-Atlas is currently behind the Sun, invisible to Earth-based telescopes, moving through its perihelion passage at speeds exceeding 68 km/s, bathed in solar radiation that could trigger outgassing, fragmentation, or surface changes, positioned at the optimal point for any propulsive maneuver, natural or otherwise. And in 40 days, when it emerges from the Sun's glare, the entire planetary defense network will be watching. Every major observatory, every participating astronomer, every instrument capable of tracking a fast-moving target in the pre-dawn sky. They're not telling us to panic. They're not telling us to prepare. They're telling us this is a training exercise, an astrometry workshop, a chance to improve measurement techniques, and maybe that is exactly what it is. Maybe the activation of Aujourd'Hui is purely procedural. Maybe the closed registration and coordinated observation window and suspicious timing are all just standard protocol for any interesting interstellar visitor. Maybe the silence on the Mars flyby images is just bureaucratic delay. Maybe there is nothing unusual about 3U Atlas beyond its interstellar origin and its enormous size and its strange spectroscopic signature and its anomalous brightness, offset, and its perfectly timed perihelion during solar conjunction. Or maybe, just maybe, they're watching something that has already given them reason to activate planetary defense. Something they saw in those unreleased high-rise images. Something in the trajectory data that does not fit the models. Something that justifies spinning up the global coordination network and organizing a 2-month surveillance campaign under the cover of an astrometry training exercise. We will find out in December when the observation window opens, when 3 Elas emerges into the morning sky, low on the horizon moving through Virgo. When hundreds of telescopes track its position, every night measuring its velocity, its brightness, its spectral signature, its stability. When the data comes in and gets analyzed and compared against the predictions, when we see if it follows the expected orbit or if something changed during those hidden weeks behind the sun. For now, all we have is a bulletin, 16 lines of text, an editorial notice about an astrometry campaign, and the quiet, understated activation of humanity's planetary defense network. For an object that poses no threat, for a visitor that will pass at a safe distance, for a comet that should not require the coordination of IAWN. Unless it is not just a comet, unless there is more to this story than the official narrative, unless someone somewhere saw something in the data that made them decide it was time to activate the network, time to coordinate the global response, time to watch very carefully what happens next. The countdown has started. November 27th, the observation window opens. December 19th, closest approach to Earth. January 27th, the window closes. And somewhere in that timeline, we will learn if this was just an exercise or if it was preparation for something we're not yet ready to acknowledge. Chapter 2, The Whistleblower Bombshell. 12 hours after that bulletin appeared, someone broke their silence. Not through official channels, not through a press release or a scientific paper, through a social media post that has now been viewed millions of times and sparked a firestorm of speculation that space agencies around the world are refusing to address. A person claiming to be a space debris engineer and analyst at the European Space Agency stepped forward with information they say the public deserves to know. Information about 3 Atlas that, if true, changes everything we think we understand about this object. The post appeared on platform X on October 21st at approximately 1900 hours Universal Time. The account, which had been relatively quiet for months, suddenly posted a detailed thread claiming insider knowledge of ESA operations and access to data that has not been shared with the broader scientific community. The core claim is extraordinary. According to this alleged insider, the Fermi Gamma Ray Space Telescope detected a stable signature coming from 3Y Atlas in mid-September. Not a burst, not a fluctuation, a constant stable emission that does not match any known natural source in the database. Let me be very precise about what that means. The Fermi telescope is designed to detect gamma rays, the highest energy form of light in the universe. Natural sources of gamma rays include pulsars, black holes, supernova remnants, and active galactic nuclei. These sources produce characteristic patterns. Pulsars pulse, black holes flare, supernovae fade over time. Each has a signature, a fingerprint in the data that tells you what you are looking at. What FMI allegedly detected from 3/5 at Atlas is none of those things. It is described as stable, continuous, artificial. The whistleblower uses specific language. They say the signature is not attributable to any other space source. That is not casual phrasing. That is the kind of language you use when you have checked every natural explanation and ruled them all out. That is the language of someone who has seen something they cannot explain through conventional astrophysics. And then they add the kicker. In other words, the object emits a constant engine-like sound. Now, obviously, gamma rays are not sound waves. Space is a vacuum. There is no medium for sound to travel through, but astronomers often describe electromagnetic signals as sounds because it helps convey the pattern. A pulsar's regular beat is often sonified into a rhythmic pulse. Solar flares produce bursts of radio noise that sound like static when converted to audio. What this alleged engineer is describing as a steady hum, a constant tone. The kind of signal you would expect from a power source running at a fixed frequency. The kind of signal that does not occur naturally. According to the Post, this discovery was made in mid-September. That would be about 6 weeks ago, right around the time 3I Atlas was being observed by multiple telescopes during its approach towards Mars. Right around the time when spectroscopic analysis was revealing all those strange anomalies in its composition. Right around the time when Harvard astrophysicist Avi Loeb started publicly questioning whether this object might be something other than a natural comet. And according to this whistleblower, the Fermi data was never shared within ESA's normal analysis channels. It was flagged, isolated, restricted to a small group with clearance. The source claims they are not trying to be a hero. They're not dying of cancer. They're not laughing, which is internet slang for live-action role-playing, pretending to be something you are not. They explicitly state these things because those are common accusations leveled at anonymous whistleblowers. They say they just feel people need to know something big is about to happen. And then they add a timeline. In December, many home-based observers will see it all. December. That is when 3 Atlas makes its closest approach to Earth. That is when it will be visible to amateur astronomers with decent backyard telescopes. That is when the IAWN observation campaign will be in full swing. That is when, according to this alleged insider, whatever is happening with this object will become undeniable, visible, observable by anyone with the equipment to look. Now, let us talk about credibility. This person is anonymous. They have not provided their name or employee ID or any documentation that would conclusively prove they work for ESA. The claims cannot be independently verified because the FMI data they reference has not been publicly released. There is no way to check if this gamma ray signature actually exists. This could be an elaborate hoax. It could be someone with insider knowledge of ESA procedures using realistic jargon to spread misinformation. It could be a creative writing exercise that got out of hand. But here's what makes it interesting. The technical details are specific. The terminology is correct. The timeline matches other observed patterns. And the claim about Fermi detecting something unusual aligns with the broader silence from official sources. NASA still has not released the piracy images from the Mars flyby. ESA released only a handful of low-resolution frames from their orbiters. The most powerful instruments we have trained on this object and the highest quality data is being withheld. If the Fermi telescope did detect an anomalous signature, that would explain the radio silence. That would explain why those Mars images are not public. That would explain why IWN activated so suddenly. The whistleblower says they have been monitoring online discussions. They mention checking platforms like Reddit, YouTube, and 4chan to see how the story develops. That is either someone genuinely trying to gauge public reaction to information they believe is being suppressed, or it is someone who understands internet culture well enough to craft a believable narrative. Either way, the impact has been significant. The post went viral. It has been screenshotted, analyzed, debated in forums and comment sections across the internet. So far, space agencies have chosen silence. NASA has not commented. ESA has not issued a statement. The Fermi collaboration has not released any data related to 3I Atlas. That silence is itself meaningful. If the claims were obviously false, a simple denial would end the speculation. But when a credible-sounding source makes specific technical claims about classified observations and the response is complete silence, that tells you something. There is another layer to this. The whistleblower mentions that the Fermi detection was not shared or analyzed within ESA. That implies compartmentalization. Information siloed away from the broader scientific staff. Only certain people with certain clearances allowed to see it. That is not how scientific discoveries usually work. When a telescope detects something interesting, the data goes to the team managing that instrument. They analyze it, they write it up, they publish. The process is transparent and collaborative. But when you're dealing with something that has national security implications or could cause public panic, normal protocols get suspended. The sun just fired at it. While the Planetary Defense Network activated and whistleblowers leaked claims of engine signatures, another development unfolded that nobody predicted except for one person. Geophysicist Stephen Burns, who's been tracking 3 Flight Atlas since its discovery, posted something on October 21st that made even skeptics pause. A massive coronal mass ejection had launched from the far side of the sun. Not a routine solar flare, not a minor geomagnetic disturbance. A halo CME skewed precisely in the direction Aujourd'Hui Atlas was traveling. Direct hit impact expected in 3 to 4 days just before perihelion. Burns announced it with unmistakable excitement. Boomcha Kalaka bullseye, all caps, the kind of enthusiasm scientists rarely show in public. And then he added something even more remarkable. He had been forecasting this exact scenario for months. Not just predicting general solar activity, not just expecting the sun to be active during solar maximum. He had specifically predicted that 3I Atlas would trigger electromagnetic disruptions in the inner solar system, and that the closer it got, the more spectacular those disruptions would become. Now, on the day of solar conjunction, when 3I Atlas aligned perfectly on the opposite side of the sun from Earth, a massive CME erupted from the far side and aimed itself directly at the comet. Let us break down what a coronal mass ejection actually is, because the term gets used casually, and most people do not grasp the sheer violence involved. The sun's corona, its outer atmosphere, is held in place by magnetic fields that loop and twist as the sun rotates. Sometimes those fields become unstable. They snap. When that happens, billions of tons of plasma, superheated gas, get flung into space at speeds ranging from hundreds to thousands of kilometers. That ejected material carries its own magnetic field, and when it slams into planets, spacecraft, or comets, it can trigger geomagnetic storms, auroras, and in extreme cases, damage to electrical systems and satellites. For Earth, CMEs are a known hazard. We have magnetosphere protection, but strong enough CMEs can still disrupt power grids and communications. For a comet, especially one that is already outgassing and surrounded by a coma of gas and dust, a CME impact is transformative. The magnetic field carried by the CME interacts with the charged particles in the coma. It can tear away parts of the tail. It can compress the coma on one side and stretch it on the other. It can trigger sudden brightening as the solar wind pressure spikes. And if the comet has any internal structure that responds to electromagnetic forces, a CME impact would be the ultimate stress test. Stephen Burns has been arguing for months that 3I Atlas is not just passively moving through the solar system. He believes it is actively altering the electrodynamics around it. That as the comet heats up and releases more charged particles, it creates a disturbance in the local electromagnetic environment, a ripple that propagates outward and interacts with the sun itself. In his model, 3 Atlas is not just another comet, it is a massive source of plasma and ions. And as it approaches the sun, it changes the magnetic field structure in ways that make solar eruptions more likely. This is not mainstream solar physics. Most scientists would say the sun's activity is driven by internal dynamics, by the buildup and release of magnetic energy in active regions on the solar surface. The idea that a comet, even a large interstellar one, could influence solar activity from millions of kilometers away is considered fringe. But Burns has been documenting correlations. In August, when 3Y Atlas was still far from the sun, massive eruptions occurred in the direction of the comet and Mars. Eruptions that Burns predicted based on his electromagnetic interaction model. And now in October, at the moment of solar conjunction, when 3I Atlas is aligned directly behind the sun, another eruption, another direct hit, another validation of his months-old forecast. The CME itself is extraordinary. Burns describes it as originating from a far-side solar flare, possibly even a double-digit X-class event. X-class flares are the most powerful category of solar flare. They release as much energy as billions of nuclear bombs. A double-digit X-class flare, something like an X10 or X20, is a once-in-a-decade event. And according to Burns, this eruption happened on the side of the sun we cannot see from Earth, aimed directly at 3U Atlas as it passed through superior conjunction. We do not have direct data on the flare that caused this CME. The far side of the sun is not visible to Earth-based telescopes, and our solar observatories are positioned to monitor the sun from Earth's perspective. But we can infer the flare's magnitude from the structure and speed of the ejected material. Halo CMEs, the kind that appear as a bright ring expanding outward from the sun in chronograph images, typically come from powerful flares. And the fact that this halo CME is skewed in the direction of 3 Iles's motion suggests it was launched from a region on the far side that happened to align with the comet's trajectory. The timing could not be more significant. 3M Atlas reaches perihelion on October 29th. The CME impact is predicted for October 25th or 26th. That gives the comet roughly 3 days post-impact to react before it hits the point of maximum solar heating and gravitational stress. If the CME is going to trigger any kind of unusual behavior, any fragmentation, any trajectory change, any emission of secondary objects, it would happen in that window and we will not see it. Earth-based telescopes cannot observe 3 White Atlas during solar conjunction. It is hidden behind the sun's glare. The only spacecraft with any chance of observing the aftermath are those positioned away from the Earth's sunline, Solar Orbiter Parker Solar Probe, and neither has publicly announced any observation plans for 3 Yatlas during this period. Burns emphasizes that this is not a coincidence. He's been forecasting this exact sequence of events since early August. 3 for Atlas approaches the sun, its plasma emissions increase, the electromagnetic environment becomes unstable, solar activity spikes, eruptions occur in the direction of the comet. The closer 3I Atlas gets, the more intense the activity becomes. And now, at the critical moment at solar conjunction, when the comet is perfectly aligned on the far side of the sun, the largest CME of the sequence erupts and heads directly toward it. There is a philosophical question embedded in this observation. Can a comet influence the sun? Can a relatively small object, even one several kilometers across, alter the behavior of a star 1,000,000 times more massive? In conventional astrophysics, the answer is no. The sun's magnetic field and plasma dynamics are driven by processes deep in the solar interior. Surface phenomena, like flares and CMEs, are triggered by the buildup and release of magnetic energy in active regions. A comet passing nearby would be like a mosquito buzzing past an elephant, insignificant beneath notice. But Burns is proposing something more subtle. Not that 3I Atlas is directly causing solar flares through gravitational or magnetic forces. That would be absurd. Instead, he's suggesting that the plasma and charged particles released by the comet create a pathway, a channel through which the sun's existing magnetic energy can release more easily. Like how a lightning rod does not create lightning but provides a preferential path for existing electrical potential to discharge. In this model, 3 Atlas does not power the flares. It triggers them. It provides the conditions that make eruptions more likely in certain regions of the sun. There is precedent for objects affecting plasma environments. Spacecraft traveling through planetary magnetospheres often trigger electromagnetic waves and particle acceleration. Io, the volcanic moon of Jupiter, pumps ions into Jupiter's magnetosphere and powers some of the most intense auroras in the solar system. Comets that pass close to the sun can create disturbances in the solar wind that propagate outward for millions of kilometers. The idea that a very large, very active interstellar comet could influence the local electromagnetic environment enough to affect solar dynamics is not impossible. It is just not proven. And it requires a level of activity from 3Y Atlas that goes beyond what we typically see in comets. Burns describes 3 Atlas as gushing water, not outgassing in the normal cometry sense, gushing, releasing enormous quantities of water vapor at distances from the sun where most comets would still be frozen and inactive. This level of activity has been documented. Papers published in September noted that 3 Atlas was producing water at a rate described as a fire hose, detectable at more than 3 astronomical units from the Sun. That is unusual. Most comets do not become highly active until they are much closer to the Sun inside 2 astronomical units. 3. Atlas started gushing early and has not stopped. That amount of water vapor means a corresponding amount of ions. Water molecules in the solar wind get ionized, broken apart into hydrogen and oxygen ions. Those ions interact with magnetic fields. They form structures called ion tails, invisible in normal light but detectable with specialized instruments. And if 38 is releasing as much water as the observations suggest, then it is creating a massive cloud of ions around itself. A cloud that extends for millions of kilometers. A cloud that interacts with the solar wind, the Sun's magnetic field, and anything else that passes through it. The CME impact will interact with that ion cloud. When the CME's magnetic field collides with the comet's ion environment, you get what is called magnetic draping. The solar wind magnetic field wraps around the obstacle, creating complex structures and potentially accelerating particles to high energies. For a comet as active as 3 for Atlas, a CME impact could trigger a cascade of effects: sudden brightening, tail disconnection events, changes in the emission spectrum, and if there is any solid structure within the coma, any nucleus or artificial object, the electromagnetic forces could exert pressures that reveal its presence. Burns is not claiming 3 Atlas is artificial. He is not making the leap to alien spacecraft, but he is documenting behavior that is extraordinary, even for an interstellar comet. He's showing that this object is affecting its environment in ways that are detectable, predictable, and unlike anything we have seen from previous visitors. And now, at the moment when 3 is most vulnerable, most active, most hidden from Earth's view, the Sun has fired a direct shot. 1 billion tons of plasma moving at 1,000 km/s, aimed precisely where the comet will be in 3 days. What happens when they collide? We do not know. We cannot observe it directly. The best we can do is watch for the aftermath. When 3I-8 emerges from solar conjunction in November, we will see if it is still intact, if it fragmented, if its brightness changed unexpectedly, if its trajectory deviated from predictions. Those observations will tell us whether the CME impact was just another comet interaction or something more significant. Burns calls the correlation pretty cool to see play out. That is a remarkable understatement. He predicted months ago that 3I Atlas would trigger solar activity during its approach. He specified that the activity would peak near perihelion. He documented eruptions in August that supported his model. And now, on the day of solar conjunction, the largest eruption of the sequence occurs exactly as he forecasted. That is not luck. That is either a validated physical model or a series of coincidences so improbable that they demand explanation. The electromagnetic interaction hypothesis has implications beyond just solar activity. If 3I Atlas is genuinely altering the plasma environment around it, if it is creating disturbances that propagate through the solar wind, then it is doing something unusual. Natural comets affect their immediate surroundings, but the effects are localized and short-lived. What Burns is describing is a larger-scale interaction, a feedback loop between the comet's emissions and the Sun's magnetic field, a relationship that builds over time and culminates in coordinated eruptions at critical moments. And there's another layer to this. If the electromagnetic environment is being altered, if there are unusual plasma dynamics at play, then instruments like Fermi might detect anomalous signatures. Gamma rays can be produced by particle acceleration in strong magnetic fields. If the CME impact creates conditions where particles are accelerated to extremely high energies, you could see gamma ray emissions that would not occur under normal cometry conditions. That might explain the alleged Fermi detection. Not an engine, not artificial power generation, just an extraordinarily active comet in an extraordinarily dynamic electromagnetic environment, producing emissions that mimic what you would expect from a technological source. Or maybe both things are true. Maybe 3I Atlas is artificially enhancing its own plasma output. Maybe it is deliberately creating conditions that trigger solar activity. Maybe the CME impact was not an accident, but a calculated interaction. Maybe the timing, the alignment, the precision of the eruption all point to something more than natural processes. We are left with layers of possibility, each one plausible, each one consistent with some of the data, none of them confirmed. Stephen Burns will keep watching. He has positioned himself as the one person who saw this coming, the one who predicted the solar activity when everyone else was focused on spectroscopy and orbital mechanics. If his model continues to hold, if more eruptions occur as 3 Zeta Atalis approaches and departs perihelion, then his voice will carry more weight, the fringe hypothesis will become harder to dismiss, and the question of what 3 Atlas actually is will grow more urgent. The CME is in flight now, moving through space at over 1 million kmh. It will reach 3 Atlas in days. The comet hidden behind the sun will take the full force of the impact, and we will watch the sun. We will watch for more eruptions. We will watch for any sign that the electromagnetic dance between star and comet is continuing. And when 3I Atlas emerges into view in November, we will see what the collision left behind. Hiding behind the sun, the perfect cover. There is a window of time where anything could happen and we would never see it. That window opened on October 21st and will not close until mid-November. For those weeks, 38 Atlas is positioned directly behind the sun from Earth's perspective, completely invisible to our telescopes, moving through the most critical phase of its journey. And this is not an accident of orbital mechanics. This is not random chance. The timing is too perfect, the alignment too precise. Solar conjunction happens to coincide exactly with perihelion, the moment when the comet is closest to the sun, moving fastest, experiencing maximum gravitational and thermal stress, is also the moment when it is most completely hidden from observation. Activé asked the question that everyone thinking about this trajectory has been avoiding. Was this hideout planned? Was the timing of solar conjunction and perihelion deliberately chosen? He frames it in the language of astronautics, spacecraft design, of optimal trajectory planning. And the answer from a purely engineering perspective is that if you wanted to perform a major maneuver unobserved, if you needed to alter your course or deploy secondary objects or change your configuration, you could not pick a better moment than perihelion during solar conjunction. It is the ultimate blind spot. The Obath effect is fundamental to understanding why this timing matters. In astronautics, when you want to change a spacecraft's orbit, you do not fire your engines just anywhere. You wait until you're moving fastest, until you're closest to the massive body you're orbiting or passing. At that point, a small amount of thrust produces the maximum change in kinetic energy. It is counterintuitive. You would think that firing engines when you're moving slowly would be more efficient, but the mathematics says otherwise. The faster you're moving when you apply thrust, the more dramatic the change in your final trajectory. For 3I Atlas, perihelion is that moment on October 29th. It will be moving at roughly 68 km/s relative to the sun. That is the fastest it will ever move in our solar system. That is when a propulsive burn, if one were to occur, would have maximum effect. If you wanted to slow down from interstellar speed and enter a bound orbit around the sun, this is when you would do it. If you wanted to adjust your trajectory to intercept Earth at a later date, this is when you would set up that intercept. If you wanted to separate into multiple objects that would follow slightly different paths, this is when you would initiate the separation. And all of this happens while Earth cannot see. Our telescopes point at the sun every day, but we cannot look directly at the sun without specialized equipment. And even then, we can only see the sun itself, not objects hiding behind it. 3. I-8 is not just behind the sun. It is in the solar glare, the region where the sun's brightness overwhelms everything around it. Even if a telescope were pointed in the right direction, the light from the sun would drown out any signal from the comet. For roughly 4 weeks from mid-October to mid-November, 3Y Atlas is functionally invisible to Earth-based observation. The solar illumination at perihelion is staggering. With a minimum diameter of 5 kilometers, 3Y or Atlas will receive more than 33 GWs of solar power on its surface. 33 GWs. That is the output of dozens of large power plants. That is enough energy to power entire cities, and all of that energy is being absorbed by the surface of the comet, heating it, sublimating ice, driving out gassing, potentially powering processes we have not considered. For a natural comet, that energy causes straightforward effects. Ice turns to vapor. Dust gets lifted off the surface, the coma expands, the tail grows, brightness increases. All predictable, all well understood. But if there is anything more complex happening, if there is any structure beneath the surface, any mechanism that responds to thermal input in non-standard ways, 33 GW is enough to power it, enough to run engines, enough to generate thrust, enough to deploy secondary systems. Lowe points out that if 3 Atlas maintains a trajectory shaped by gravity only, we will be able to track it after perihelion and confirm that nothing changed. Its closest approach to Earth on December 19th will happen exactly where the models predict. The velocity will match, the brightness will match, everything will fit the natural comet hypothesis. But if anything deviates, if the trajectory shifts even slightly, if the arrival time at Earth is off by hours or days, if the brightness does not match the expected curve, then we will know something happened during those hidden weeks. Something that altered the comet's path, something that cannot be explained by gravitational forces alone. The phrase alien tech masquerading as a natural comet appears in Lowe's essay not as a definitive claim, as a question, as a hypothesis that must be considered given the timing and the circumstances. He notes that Halloween falls on October 31st, 2 days after perihelion. The symbolism is not lost on anyone, the scariest day of the year. And we're wondering if the interstellar visitor currently hiding behind the sun might be something other than what it appears. There is a deeper question embedded in all of this. Why would an advanced civilization design a spacecraft to look like a comet? Why the disguise? The most obvious answer is reconnaissance. If you want to study a solar system without alerting the inhabitants, you do not arrive in an obviously artificial craft. You arrive in something that could plausibly be natural. An interstellar comet is perfect. It has a reason to be on a hyperbolic trajectory. It has a reason to be approaching the sun and passing through the inner system. It has a reason to be outgassing and surrounded by a coma that obscures any internal structure. From a distance, it looks exactly like what we expect interstellar comets to look like. Only up close, only with detailed spectroscopy and high-resolution imaging, do the anomalies become apparent. And if you're going to perform any actions that might reveal your artificial nature, you do them when you are unobservable. You wait for solar conjunction. You use the sun as cover. You make your adjustments, deploy your instruments, reconfigure your systems, all while hidden from the very civilization you are studying. Then you emerge on the other side, resume your trajectory, and by the time anyone notices any discrepancies, you're already past perihelion and moving away. Too late to intercept, too late to study up close, just late enough that the data is ambiguous and the debate can continue forever. ESA's JUICE spacecraft will pass within 64 million kilometers of Thrive Asilas on November 4th. That is shortly after perihelion, after the comet has emerged from the worst of the solar glare, but before it is fully visible from Earth. JUICE has cameras, spectrometers, particle sensors. It is not designed to study comets, but it can turn its instruments toward 3Y Atlas and collect data. If the comet fragmented during perihelion, JUICE might see the debris field. If the trajectory changed, JUICE can measure the new path. If there are emission anomalies, JUICE can detect them. This will be our first independent look at what happened during the hidden window. NASA's Juno spacecraft will have a turn in March 2026 when 3 Pleiades passes within 54 million kilometers of Jupiter. Juno has ultraviolet spectrographs, infrared mappers, microwave radiometers. It can analyze the comet's composition, look for thermal anomalies, detect any unusual emissions. By that point, 3I Atlas will have been observable for months. We will have trajectory data from November and December. We will know if it behaved as predicted or if something changed. Juno's observations will add another layer of verification, another data set to compare against the models. But the critical moment is perihelion October 29th. and we will not see it happen. We will infer it from the aftermath, from what 3 Atlas looks like when it emerges, from whether its trajectory matches the predictions, from whether it is still a single object or was split into multiple fragments, from whether the spectral signature changed, from whether new emissions appear that were not there before. Lowe suggests monitoring the sky in November and December for any unusual activity or any new objects that came out of 3 Atlas. That phrasing is specific, new objects, plural. The idea being that if 3I Atlas is a mothership, if it carried smaller probes or instruments, perihelion would be the optimal time to release them. The tidal force from the sun would then separate their trajectories over the following months. By December, they would be spread out enough to be distinguishable as separate objects rather than parts of a debris cloud. And if that happens, if telescopes start detecting multiple objects in slightly different orbits, all originating from the same point during perihelion, the natural comet explanation collapses. There is also the possibility of fragmentation. Natural comets can break apart when they get too close to the sun. The thermal stress, the outgassing pressure, the tidal forces, all combine to pull weakly bound material apart. Comet Shoemaker-Levy 9 famously fragmented into 21 pieces before colliding with Jupiter. Other comets have disintegrated entirely during close solar passes, leaving nothing but debris clouds. If 3 Y-Atlas fragments naturally, we would expect to see a characteristic pattern. A string of objects along the same orbit, gradual separation over time, no organized structure, no coordinated behavior. But if 3 Illas deliberately releases secondary objects, the pattern would be different. Controlled separations, velocity kicks that send the objects onto diverging paths, possibly even different types of objects with different sizes and behaviors. That is the signature of intelligent action versus random breakup. And December is when we would start to see the pattern emerge, when the separation between objects becomes large enough to measure, when independent observers can track multiple targets and calculate their individual orbits. The choice of December 19th for closest approach to Earth is also interesting. That date is not arbitrary. It falls during a time of year when the Northern Hemisphere has long nights and relatively clear skies in many locations. Amateur astronomers will have extended observation windows. Telescopes in both hemispheres can track the comet, and 3I Atlas will be in Virgo, a constellation well placed for observation in the pre-dawn sky. If something unusual is going to be visible, December is the month when the most people will be watching with the most time to collect data. Lowe ends his essay with a call for evidence-based science, not expectations, not assumptions, evidence. The data from November and December will tell us whether 3I Atlas maintained a gravitational trajectory or whether something else happened. We do not need to speculate. We need to observe, measure, and analyze. The universe will provide the answer if we are paying attention. But the timing still haunts the analysis. Solar conjunction during perihelion, the optimal maneuver window during the optimal concealment period, maximum solar energy input during maximum invisibility. It is the perfect setup for a covert operation. And whether that perfection is coincidence or design is the question that will define how we interpret everything that happens next. If 3 Itals emerges unchanged, following the predicted path, showing no anomalies, then the coincidence stands, remarkable, but ultimately meaningless. Just another case of humans seeing patterns where none exist. But if anything is different, if there is any deviation, any new object, any unexplained emission, then the coincidence becomes evidence. Evidence that the timing was not random, that the trajectory was not accidental, that 3I Atlas knew exactly when and where to make its move, and that we're only now beginning to understand what we're actually dealing with. The sun has provided the perfect cover. The question is whether anyone is using it. The industrial alien alloy mystery. The spectroscopic data should have been straightforward. Point a telescope at a comet, measure the light coming from its coma, identify which elements are present based on their emission lines. For solar system comets, the results are predictable. Water vapor, carbon dioxide, dust, traces of metals like sodium and iron, usually in small amounts released as the nucleus heats up. Nothing controversial, nothing that rewrites the textbooks. But 3 Atlas does not follow that script. When the KEK-2 telescope in Hawaii analyzed the comet on August 24th, it detected something that should not exist in nature: nickel emissions without iron, and not just trace amounts. 4 g of nickel per second streaming off the object with no detectable iron accompanying it. That ratio is wrong, cosmically wrong. In every natural environment we have ever studied, nickel and iron appear together. They're forged together in stellar nucleosynthesis. They condense together in protoplanetary disks. They're chemically similar with almost identical properties. So they behave the same way in geological and thermal processes. When you find one, you find the other, always except in 3 Atlas, where nickel is abundant and iron is absent. Avi did not mince words when he saw the data. There is only one place where that is known to exist, and that is in industrially produced nickel alloys. He was referring to a specific compound, nickel tetracarbonyl, a chemical that forms when nickel reacts with carbon monoxide under specific conditions. Those conditions do not occur naturally in comets. They occur in human manufacturing facilities, in processes designed to purify nickel or coat surfaces with nickel plating. It is an industrial chemical, a product of deliberate engineering. And according to the spectroscopic data, 3I8LUS is producing it by the kilogram. Nickel tetracarbonyl has a very particular use in technology. It is part of the bond process, a technique for refining nickel to extremely high purity. You start with impure nickel ore. You expose it to carbon monoxide at moderate temperatures. The nickel forms a gaseous compound nickel tetracarbonyl, which you can then separate from impurities. Heat it again, and the compound breaks down, depositing pure nickel metal. It is elegant, efficient, and uniquely suited for industrial applications where you need very pure nickel, such as in aerospace alloys, electronic components, or surface coatings for equipment that must withstand extreme conditions. The aerospace connection is not subtle. Nickel-based superalloys are used in rocket engines, in spacecraft structures, in anything that needs to resist high temperatures and mechanical stress. They're essential for advanced propulsion systems. And now, we have an interstellar object emitting a nickel compound that is primarily known from industrial purification processes and aerospace manufacturing. The implications are uncomfortable. Either we are witnessing a natural process that mimics industrial chemistry so closely that it produces the exact same compounds, or we are witnessing actual industrial chemistry happening on an object that is supposed to be a frozen ball of ice and rock. The Keck data also showed something else unusual. The emission profiles of both nickel and cyanide around 3 Atlas are asymmetric. There is extension in both the solar and anti-solar directions. That creates what astronomers call an anti-tail, a structure that appears to point toward the sun instead of away from it. Normal comet tails point away from the sun because solar radiation pressure pushes dust and gas outward. An anti-tail suggests internal activity, pressure from within the nucleus ejecting material in multiple directions, not just the direction dictated by solar wind. That kind of activity requires energy, a lot of energy. More than you would expect from simple ice sublimation. The production rate of nickel relative to cyanide is orders of magnitude above the solar system comet median. Orders of magnitude, that means not just a little higher, not twice as much or 5 times as much, hundreds or thousands of times more nickel than any known comet produces. And cyanide itself is interesting because it indicates organic chemistry. Carbon-nitrogen bonds, the building blocks of more complex molecules. Combined with the nickel emissions, you have a chemical environment that is simultaneously organic and metallic, biological precursors mixing with industrial compounds. It is a strange combination, not impossible, but deeply unusual. Researchers from the Keck Observatory noted that while this phenomenon is rare, a new study suggests it could be natural. That qualifier could be is doing a lot of work in that sentence. It is not saying the process is understood. It is not saying there is a clear natural mechanism that explains the observations. It is saying that they have not yet ruled out natural explanations, which is a very different claim. Science operates on the principle that you exhaust all mundane possibilities before invoking extraordinary ones. But when the mundane possibilities require novel chemistry that has never been observed in any other comet, you have to ask how far you stretch the definition of mundane. The absence of iron is particularly troubling. Iron is one of the most abundant elements in the universe. It is a major component of rocky bodies, metallic asteroids, and the cause of planets. In comets, iron appears alongside nickel because both were incorporated into the comet during its formation. The fact that 3Y Atlas shows strong nickel emissions but no corresponding iron suggests either extreme fractionation during formation, which would require very specific and unlikely conditions, or active separation of nickel from iron, which would require a process that preferentially releases one element while retaining the other. In industrial settings, that separation is exactly what nickel refining accomplishes. You extract pure nickel by converting it to a compound that can be isolated from iron and other impurities. If 3-3 Atlas were a spacecraft, if it had nickel-based structural components or surface coatings, thermal stress during solar approach could cause outgassing of nickel compounds. The carbon monoxide needed to form nickel tetracarbonyl could come from organic material on the surface or from the breakdown of more complex carbon-bearing molecules. The heat from the sun provides the energy. The chemistry happens spontaneously once the conditions are right, and what you see from Earth is exactly what the KEK telescope detected. Abundant nickel, no iron, a chemical signature that matches industrial processes. But here is where it gets more complicated. The Very Large Telescope in Chile, using its UVEST spectrograph, obtained additional data in early October. Those observations confirmed the anomalous nickel-to-iron ratio. They also noted that the presence of nickel and iron atoms in cometary spectra is generally unexpected because surface temperatures are too low for sublimation of refractory minerals. Refractory means high melting point. Metals, nickel and iron, should not be vaporizing at the distances where 3I Atlas is showing these emissions. The comet would need to be much hotter, or there would need to be a different mechanism releasing the metals. One possibility is collisional ejection. Tiny particles collide, fracture, release atoms into the coma. Another is photosis. Ultraviolet light from the sun breaks apart molecules containing the metals. But those processes should release iron and nickel together, not separately. The fact that iron is missing, or at least undetectable, points to something more selective happening, something that preferentially mobilizes nickel. The antail is another piece of the puzzle. Normal comet tails are pushed away from the sun by radiation pressure and solar wind. But 38 Atlas has a stream of material visible in multiple wavelengths that extends toward the sun. The explanation offered in the papers is that large dust grains too heavy to be blown back by radiation pressure are ejected by internal activity and follow ballistic trajectories. Some of those trajectories, depending on the ejection velocity and angle, can create the illusion of an anti-tail when viewed from Earth. It is a geometric projection effect, except 3I less has emission in both nickel and cyanide in the anti-tail. Not just dust, gas molecules that are light enough to be affected by radiation pressure, but are somehow still appearing in the sunward direction. That requires active ejection. Jets of gas and dust coming from the nucleus with enough velocity to overcome solar pressure, at least temporarily. And jets require pressure. They require venting. They require a mechanism that builds up pressure beneath the surface and releases it suddenly. That can happen naturally in comets when pockets of volatile ice sublimate rapidly. But the symmetry of the emissions, the consistency, the fact that it is happening across multiple wavelengths, all suggest something more organized than random outgassing. Lowe described the situation as a comet that does not exhibit a cometary tail and whose trajectory is fine-tuned to align with the orbital plane of the planets around the sun. Insisting that 3 Atlas must be a comet is unwise, he wrote, because it does not behave like one, and he's not wrong. The white light images of 3 Atlas do not show a familiar cometary tail. There is a coma. There is some diffuse structure, but the long, sweeping dust tail that we associate with bright comets is absent or extremely faint. For an object this large, this active, this close to the sun, you would expect a dramatic tail. Instead, you get ambiguity, structure that is hard to interpret, emissions that do not fit the standard model. The chemical fingerprint is the strongest anomaly. Nickel tetracarbonyl does not appear in nature. It is a human invention, a compound we synthesized for specific industrial purposes. Finding it, or something spectroscopically indistinguishable from it, in the coma of an interstellar comet means either we have discovered a new natural process that independently produces the same compound through completely different chemistry, or we are looking at the residue of industrial activity. Occam's razor would normally favor the natural explanation. The universe is vast. Strange chemistry happens. But when the strange chemistry produces exactly the compounds used in aerospace manufacturing, and those compounds appear on an object with multiple other anomalies, the razor starts cutting the other direction. There's also the issue of scale. 4G of nickel per second. Over the course of weeks or months, that adds up to tons of material. Where is it coming from? How much nickel does 3S contain? If it is a natural comet, nickel would be a trace element locked in mineral grains released slowly as the nucleus erodus. You would not expect kg of nickel over the entire active lifetime of the comet, let alone g/second. If it is artificial, if there are nickel alloy structures on or within the object, then the outgassing makes more sense. Surface coatings, structural components, heat shielding, all could release nickel compounds under thermal stress, and the quantities could be substantial if the structures are large. The researchers working on this data are careful. They do not claim 3-Atlas is artificial. They document the anomalies. They note the unusual ratios. They suggest that natural processes might explain it, but they do not provide a detailed mechanism. They do not explain how a comet produces industrial-grade nickel compounds without producing iron. They leave that question open. And in science, an open question is an invitation. An invitation to propose alternatives, to test hypotheses, to push the boundaries of what we consider possible. The nickel emissions will continue as 3C Atlas moves through perihelion. If anything, they might intensify as the comet gets closer to the sun and temperatures rise. JUICE and Juno will both have spectrometers capable of analyzing the emissions. We will get more data, better resolution, longer observation periods, and we will see if the nickel-to-iron ratio persists, if it changes, if new compounds appear. Each measurement will either reinforce the anomaly or provide a path to explaining it naturally. But right now, today, based on what the KEK telescope and the Very Large Telescope have shown us, 3 Vitals is emitting a chemical that should not exist in a comet, a chemical that is synonymous with industrial nickel processing. A chemical that appears in aerospace alloys and surface treatments, a chemical that requires specific conditions to form, conditions that are not typically found in the cold vacuum of space unless someone built something and left it there. Unless we're looking at the exhaust from a manufacturing process that happened light years away and is now venting into our solar system as the structure heats up and degrades. The alternative is that the universe is stranger than we thought. That tree chemistry is more diverse than our models predict. That nickel tetracarbon forms naturally under conditions we have not yet identified. That 3I Atlas is simply the first example of a new class of interstellar comet with exotic composition and unusual thermal behavior. That everything is natural, just unexpected. That explanation is possible. It is even likely from a statistical standpoint, but it requires us to accept that an interstellar visitor independently evolved chemistry that mirrors human industrial processes. And that coincidence, that perfect alignment between what we make and what nature produces, is harder to swallow with each new data point. October 30th, the consciousness event. While scientists debated nickel ratios in orbital mechanics, another narrative emerged from an unexpected direction, not from observatories or academic papers, from social media. From a video that went viral in mid-October, claiming that October 30th, 2025, at exactly 11:44 Universal Time, would mark a global consciousness shift. Not metaphorically, literally. An electromagnetic event triggered by the convergence of 3 cosmic phenomena. The Sun at solar maximum, 3Y Atlas reaching perihelion, and Earth's magnetic field at its weakest point in decades. According to the video, these 3 factors would combine to amplify Earth's natural frequency, the human resonance, to levels never before experienced in recorded history. And when that happens, 6.2 billion people, roughly 76% of humanity, would undergo simultaneous neurological synchronization, a planetary awakening, a consciousness event. The video is polished, well-produced. The speaker presents complex ideas with confidence. Using scientific terminology mixed with spiritual concepts, he talks about the human resonance as Earth's heartbeat 7.83 Hz, the frequency at which the space between Earth's surface and the ionosphere naturally resonates, driven by lightning strikes around the planet. He explains that this frequency matches the theta brainwave range, the state associated with deep meditation, creativity, and altered consciousness. The implication is that Earth and human brains are naturally tuned to the same frequency, that were literally synchronized with the planet's electromagnetic field. Then he introduces the trigger. On October 30th, 3 massive events converge. First, the sun is at solar maximum, more active than it has been in 20 years. Solar flares, coronal mass ejections, magnetic pole reversals, the works. Second, 3Y Atlas reaches its closest point to the sun, a city-sized object from another star system glowing, outgassing, interacting with the solar wind in ways we're still trying to understand. Third, Earth's magnetic field is at its absolute weakest point in the current cycle. The protective shield that normally buffers us from solar radiation and cosmic rays is thinner than usual, more permeable, more vulnerable to external influences. When these 3 factors hit at once, the video claims Earth's frequency will be amplified 10 times or more. Instead of 7.83 Hz, you're looking at 78 Hz or higher hitting your brain. And human brains have no choice but to sync up. That is just how entrainment works. It is neuroscience. When an external frequency is strong enough, neural oscillations adjust to match it. Your brain waves lock onto the external signal. You cannot resist it, you cannot ignore it. Your neurons fire in rhythm with the planetary field, and your consciousness shifts into a state you've never experienced before. The math presented in the video is seductive. Research shows that you need the square root of 1% of the population to create global change. For 8 billion people, that is 90,000 minds synchronizing at the same time. But with this electromagnetic disruption, we are looking at 2 billion people syncing up simultaneously. That is 22,000 times what you need for critical mass. The mathematics of consciousness, the video explains, says this will create a global field effect, a resonance that propagates through the entire human population, pulling more and more people into coherence until the synchronization becomes self-sustaining. Then comes the brainwave breakdown. Normal consciousness operates at about 20 Hz, beta waves, your everyday thinking, planning, problem-solving state. But when Earth's frequency explodes, your brain goes to 100 Hz bandwidth or more. You access gamma waves, 40 Hz, 80 Hz, 200 Hz. These are the frequencies associated with higher consciousness, enlightenment, peak performance, even psychic abilities, states that meditators spend years trying to achieve, states that mystics describe as transcendent. And on October 30th, according to this theory, 6.2 billion people will experience those states simultaneously, whether they are ready or not. The numbers keep coming. Of those 6.2 billion, 395 million have natural electromagnetic sensitivities, people who already feel shifts in weather, solar storms, geomagnetic disturbances. For them, the effect will be strongest. And 43 million people, the video predicts, will achieve a genuine transcendent state during the peak hours. Full-blown mystical experiences, ego dissolution, unity, consciousness, the kind of experiences that historically have been rare, personal, and life-changing. Except this time, tens of millions will have them at once. The peak moment is specified down to the minute 11:44 a.m. Universal Time, October 30th, 2025. That is when 3 reaches perihelion. That is when the electromagnetic alignment is perfect, but the effects build for hours before and after. From 6 a.m. to 6 p.m. Universal Time, you're looking at 12 hours of peak electromagnetic disruption. 12 hours where the human resonance is amplified, where solar activity is intense, where the magnetic field is fluctuating wildly. 12 hours of exposure to frequencies that the human brain is not evolutionally prepared to handle. And then comes the warning. Technology is going to have a bad day. GPS systems could be down for 12+ hours. Power grids will be stressed. Communication networks will be disrupted. The same electromagnetic forces that elevate human consciousness will wreak havoc on electronic systems. It is almost, the video suggests, as if the universe is telling us to disconnect from our devices and reconnect with each other and our inner awareness. While technology fails, human consciousness sources. The preparation instructions are simple. Start meditating daily, even just 10 minutes to help your brain adapt to frequency changes. Spend time in nature to ground your electromagnetic system. Stock up on essentials in case technology fails for the day. The framing is both reassuring and ominous. Reassuring because it offers concrete steps you can take. Ominous because it implies that if you do not prepare, the experience might be overwhelming. That 6 billion people suddenly experiencing altered states of consciousness could lead to confusion, panic, or societal disruption if no one is ready. The science cited in the video is real up to a point. The human resonance is a documented phenomenon. Brainwave entrainment is well studied. Solar activity does affect Earth's magnetic field. But the connections drawn between these phenomena and a global consciousness shift require leaps that mainstream science does not support. There is no evidence that a temporary increase in the Schumann resonance, even a tenfold increase, would synchronize billions of brains. There is no mechanism by which 3 fire atlas at a distance of over 200 million kilometers could directly influence Earth's electromagnetic field in the way described, and the prediction of 43 million transcendent experiences happening simultaneously is not based on any peer-reviewed research. Yet the video resonates. It has millions of views. The comments are a mix of excitement, skepticism, personal testimonies, and demands for more information. Some people report already feeling unusual energy, heightened intuition, vivid dreams. Others dismiss it as pseudoscience, as fear-mongering designed to exploit people's anxieties about solar activity and interstellar visitors. But a significant portion of viewers take it seriously. They make plans. They prepare. They wait for October 30th with a mixture of hope and trepidation. The connection to 3 White Atlas is explicit. The video describes the comet as a catalyst, not the sole cause, but an essential component of the electromagnetic alignment, an interstellar object carrying its own energy signature, interacting with the sun's magnetic field, contributing to the amplification of planetary frequencies. Whether that interaction is natural or deliberate is left ambiguous. The video does not claim 3I Atlas is artificial. It does not invoke alien intelligence, but it treats the comet as more than just a rock and ice, as a participant in cosmic events, as something that matters to the evolution of human consciousness. There is an older tradition. This taps into the idea that comets are omens, harbingers of change. In ancient cultures, comets signal the death of kings, the rise of empires, the beginning of new ages. Astronomy has stripped away the mysticism. Comets are just icy debris, leftovers from planetary formation. Nothing special, nothing meaningful. But the symbolic power persists. When an interstellar comet appears, when it behaves strangely, when it arrives at a time of global uncertainty and technological upheaval, people look for meaning. They ask if the universe is trying to tell us something. The October 30th prediction is testable. Either the electromagnetic disruption happens or it does not. Either GPS fails, power grids wobble, communication systems glitch, or they do not. Either millions of people report unusual experiences, altered states, heightened awareness, or they do not. By November the 1st, we will have data. We will have reports from around the world. We will know if October 30th was just another day, or if something genuinely anomalous occurred. But there is a subtler aspect to this theory. Even if the electromagnetic predictions are overblown, even if nothing measurable happens to Earth's magnetic field or the human resonance, the collective expectation itself creates an effect. 6 million people, tens of millions, all focused on the same moment, all anticipating a shift, all primed to notice changes in their consciousness. That collective attention is a form of synchronization, not electromagnetic, psychological, social, cultural. When enough people expect something to happen, their behavior changes. They pay more attention. They interpret ambiguous experiences through the lens of the expectation. They connect with others who share the anticipation, and the result can feel like a collective event, even if the underlying mechanism is purely human. The video concludes with a declaration. October 30th, 2025 will be the day humanity remembers as the day we evolved, not gradually over millennia, but together consciously in a single day. It is a bold claim, one that will either be vindicated or forgotten within weeks. But for now, it adds another layer to the 3E-list narrative. Another way in which this object has captured imaginations, sparked theories, and forced people to consider possibilities they would normally dismiss. 45 days to prepare, the video says. 45 days until the most significant consciousness event in human history. The mathematics says, you will never be the same. And whether that claim is grounded in electromagnetic reality or collective mythology, it has already changed how millions of people are thinking about October 30th. They're watching the sun. They're tracking 3 Fire Atlas. They're waiting to see if the universe delivers on a promise that no scientist has made, but that resonates deep in the part of the human psyche that still looks to the sky for signs and wonders. The Schumann resonance has been measured continuously since the 1960s. It fluctuates slightly based on solar activity, seasonal changes, and lightning distribution, but it remains stable around 7.83 Hz. Sudden dramatic spikes to 10 times that value have never been recorded. If such a spike occurs on October 30th, it would be scientifically unprecedented. It would require explanation. And if it happens to coincide exactly with 3I Atlas reaching perihelion, the coincidence becomes almost impossible to ignore. Geomagnetic observatories around the world monitor Earth's magnetic field in real time. The data is public. Anyone can check if there's unusual activity on October 30th. Solar observatories track CMEs, solar flares, and solar wind conditions. Space weather forecasting is routine. We will know if October 30th brings exceptional solar activity or if it is an average day. The electromagnetic hypothesis is falsifiable. It makes predictions that can be tested, and in a landscape filled with vague spiritual claims that can never be proven wrong. The specificity is refreshing. What happens if the predictions are correct? If October 30th brings widespread technological disruptions, if GPS satellites lose lock, if power grids experience unexplained fluctuations, if millions of people report altered states of consciousness, what then? Do we attribute it to 3 Atlas, to solar activity, to Earth's magnetic field? Or do we start asking whether something about this interstellar visitor is more interactive than we assumed? Whether its electromagnetic signature, natural or otherwise, is genuinely influencing systems we thought were isolated. The consciousness shift theory is easy to dismiss. It mixes science and spirituality in ways that make academics uncomfortable. It makes testable predictions based on mechanisms that are not well established. It appeals to people looking for meaning, for transformation, for evidence that we are on the cusp of something extraordinary. But dismissal is not the same as debunking. And until October 30th passes, until we see what actually happens, the theory remains a possibility. A strange, unlikely, uncomfortable possibility that an interstellar comet might be the catalyst for something far beyond orbital mechanics and spectroscopy, something that touches consciousness itself. The 8 anomalies scientists cannot explain. Let us step back from the predictions and the leaks and look at what is documented, what has been measured, peer-reviewed, published in scientific journals. Because even without invoking alien technology or consciousness shifts, 3I Atlas presents a constellation of anomalies that, taken together, make it unlike any object we've encountered. 8 distinct characteristics that do not fit comfortably within the natural comet framework. Each one could potentially be explained in isolation, but all 8 occurring in the same object. That pattern demands attention. Anomaly 1, Ecliptic Alignment 3. I Atlas travels within 5 degrees of the ecliptic plane, a flat disk where Earth and the other planets orbit. For an interstellar object arriving from a random direction in the galaxy, this is statistically improbable. Interstellar space is 3-dimensional. Objects can arrive from any angle. The odds of an interstellar comet happening to align so closely with our planetary system's orbital plane are less than 1%, maybe less than a fraction of a percent, depending on how you calculate the probabilities. The previous interstellar visitors, Oumuamua and Boris, came in at inclinations of 123° and 44° respectively. They were tilted dramatically relative to the ecliptic. 3 Atlas is nearly flat, nearly aligned, as if it chose a trajectory that would bring it close to multiple planets without requiring steep inclination changes. Anomaly 2, the anti-tail. Comet tails point away from the sun always. Solar radiation pressure and solar wind push gas and dust outward, creating the characteristic tail that streams behind the comet as it moves. But 3 Atlas has a structure that appears to extend toward the sun. Images from multiple telescopes show emission in both the solar and anti-solar directions. The explanation offered is that large dust particles are ejected with enough velocity to move sunward before radiation pressure takes over, a ballistic trajectory effect. But that explanation requires very specific ejection speeds and angles. It requires sustained directional outgassing. It requires internal pressure sources powerful enough to overcome solar radiation forces. Natural comets can produce jets, but they are typically localized and transient. 3 Atlas shows persistent symmetric anti-tail structure across multiple wavelengths. That level of organization is unusual. Anomaly 3 size, with a minimum diameter of 5 km and potentially up to 20 km, depending on albedo assumptions. 3 Atlas is enormous. MUA was estimated at hundreds of meters. Borisov was a few km at most. 3 Atlas is larger than any interstellar object we have detected. That size has implications. Bigger objects are rarer. They require more mass to be ejected from their parent star system. They're harder to accelerate to interstellar speeds. The fact that we have detected only 3 interstellar visitors and the third is the largest suggests either we are very lucky, or large interstellar objects are more common than our models predict, or size is not random. If 3 Atlas were artificial, if it were designed for interstellar travel, being large would make sense. More room for fuel, equipment, shielding, more structural stability for a journey lasting thousands or millions of years. Anomaly 4. Planetary flyby trajectory. Atlas does not just pass through the solar system on a random path. It comes close to Mars, Venus, and Jupiter. Close enough that spacecraft at those planets can observe it. Close enough that its trajectory takes it near multiple targets of scientific interest. For a natural object, this is another low-probability event. Most interstellar trajectories would miss the planets entirely, or pass near only 1 treeless threads through the inner solar system in a way that maximizes observation opportunities from multiple vantage points. That could be coincidence, or it could be targeting a reconnaissance trajectory designed to gather data on several worlds in a single pass. Anomaly 5. Nickel enrichment. The nickel-to-iron ratio is off, way off, orders of magnitude higher than any known comet. The detection of nickel tetracarbonyl or a compound spectroscopically similar to it raises the industrial chemistry question. Natural processes that concentrate nickel while depleting iron are rare and require very specific conditions. The fact that this is happening in an interstellar comet, an object that should have a composition reflecting the average abundances in its formation region, is deeply puzzling. Either 3 Atlas formed in a place with wildly anomalous chemistry, or something is selectively releasing nickel from the object. Something like thermal degradation of nickel alloy structures. Anomaly 6. Water content. Most comets are roughly 80% water ice. 3I8 is about 4% water. The bulk of its volatile content is carbon dioxide dry ice. That makes it an unusual comet even by solar system standards, and extremely unusual for an object from another star. The ratio suggests formation in a very cold environment, far from any star where carbon dioxide could condense, but water remains too volatile to be retained. Or it suggests that water has been depleted over time, either through prolonged exposure to interstellar radiation or through processes that preferentially removed water while retaining carbon dioxide. The implications for where 3 Atlas came from and how old it is are significant. An object with that composition might be billions of years older than our solar system, or it might have lost most of its water during a long active journey through the galaxy. Anomaly 7. Extreme negative polarization. When light scatters off particles, it becomes polarized. The degree and direction of polarization tell you about the size, shape, and composition of the particles. 3IE Atlas shows negative polarization values that are unprecedented among comets. Even Borisov, which was unusual in its own right, did not show polarization this extreme. Negative polarization suggests particles with very specific properties, potentially including metallic or crystalline structures, that scatter light differently than the fluffy aggregates found in typical cometry dust. This is another piece of evidence that the material surrounding 3I8LS is not ordinary comet dust. It is something more organized, more structured, potentially more processed. Anomaly 8. Arrival direction. 3 Atlas came from a direction within 9 degrees of the source of the WOW signal. The WOW signal detected in 1977 is the most famous candidate for an extraterrestrial radio transmission. It was a strong narrowband signal at a frequency consistent with intentional communication. It lasted 72 seconds and was never detected again despite repeated searches. The source direction was in Sagittarius near the center of the Milky Way. 3 Atlas came from almost the same direction. That could be pure coincidence. Sagittarius covers a large area of sky. Millions of stars are in that region, but the correlation has not gone unnoticed. If an advanced civilization sent a radio signal toward Earth in 1977 and then sent a physical probe decades later, the two would arrive from roughly the same direction in the sky. The timing would be tight. The signal travel time at the speed of light would be 48 years. The probe traveling slower would take longer. The math does not quite work unless the probe left much earlier. But the symbolism is potent. The most famous potential alien signal and the most anomalous interstellar object both from the same region of space. These 8 anomalies do not prove 3 Atlases artificial. Each one considered in isolation can be rationalized. Ecliptic alignment, low probability but not impossible. Panty tail, complex outgassing dynamics, large size. We've only detected a few interstellar objects, so our sample is biased. Planetary trajectory, coincidence, nickel enrichment, unusual chemistry, low water, cold formation environment, negative polarization, unique dust properties, wow, signal direction. Sagittarius is a big region. Any one of those explanations holds. But all 8 together, that is the challenge. The cumulative improbability. The stacking of anomaly upon anomaly until the natural explanations start feeling strained. This is where the Loeb scale comes in. The Loeb scale is a proposed framework for assessing the likelihood that an object is of technological origin. It ranges from 1 to 10. 1 means entirely consistent with natural phenomena. 10 means unambiguous evidence of technology. 3I8 Atlas ranks 4, unusual but not conclusive. It has enough anomalies to warrant serious investigation, but not enough to definitively rule out natural origins. A ranking of 4 means keep watching, keep collecting data. Do not jump to conclusions, but do not dismiss the possibility either. The ranking of 4 is significant because it justifies the response we're seeing. IAWN activation, coordinated observation campaigns, the mobilization of resources to track this object through December and beyond. A ranking of 1 or 2 would not merit that response. A ranking of 8 or 9 would trigger a very different kind of response, likely involving classified briefings and emergency protocols. 4 is the sweet spot, interesting enough to prioritize, ambiguous enough to maintain public calm, strange enough to keep scientists engaged and looking for more data. Each future observation has the potential to move 3 or 8-less up or down the scale. If JUICE detects more anomalies in November, if amateur observers see unexplained structure in December, if Juno finds emissions inconsistent with natural comets in March, the ranking goes up. If everything fits natural models, if the trajectory remains purely gravitational, if the chemistry resolves into known processes, the ranking goes down. The scale is dynamic. It responds to evidence. And right now, we are in the phase where evidence is still accumulating. Consider what happens if even one more major anomaly is confirmed. if the alleged Fermi gamma ray detection is verified, if the whistleblower claims about engine-like sounds are substantiated, if the CME impact produces effects inconsistent with cometry response. Any one of those would push 3I Atlas to a 5 or 6 on the scale. And at that point, the conversation changes. Media coverage intensifies. Funding for observation campaigns increases. The possibility of technology stops being a fringe hypothesis and becomes a mainstream debate. The 8 anomalies are also cumulative in another sense. They interact. The ecliptic alignment makes the planetary flyby trajectory more significant. The nickel enrichment combined with the anti-tail suggests internal activity beyond simple sublimation. The low water content and extreme negative polarization both point to unusual material properties. The arrival direction from Sagittarius gains weight when combined with all the other stranges. You cannot isolate the anomalies and evaluate them independently. They form a pattern. And patterns, especially patterns that align with hypotheses about artificial objects, are what scientists look for when trying to distinguish signal from noise. There is an intellectual honesty in ranking 3 Atlas as a 4. It acknowledges the anomalies without claiming certainty. It says, "We do not know what this is, and we need more information before making definitive statements." That stance is appropriate. Science progresses by accumulating evidence, not by leaping to conclusions. But it also means we're in limbo, in a state of uncertainty that will persist for weeks or months until the next round of data arrives. And in that limbo, speculation thrives. Theories proliferate. People fill the gaps with their own interpretations, their own hopes or fears about what 3 Illas might represent. The 8 anomalies are documented. They're in the scientific literature. They are not rumors or leaks. They are measurements. And measurements do not care about our preferences. They do not adjust themselves to fit comfortable narratives. They simply are. And what they are collectively is a challenge. The challenge to our assumptions about interstellar objects, about cometry behavior, about what should and should not be possible in the natural universe. Whether that challenge leads to new understanding of cometry physics or to the first confirmed detection of alien technology is the question that the next few months will begin to answer. What happens November through December? The waiting is almost over. After weeks of 3 Atlas being hidden behind the sun, after perihelion passes unobserved, after all the speculation about what might happen during that blind window, we finally get answers. The timeline is precise. November 4th, JUICE spacecraft passes within 64 million kilometers and turns its instruments toward the comet. Mid-November, 3Y Atlas emerges from solar conjunction and becomes visible again to Earth-based telescopes. Late November, the IWN observation campaign officially begins. December 19th, closest approach to Earth at 269 million kilometers. And throughout that entire period, hundreds of telescopes, professional and amateur, will be watching, collecting data, looking for anything that deviates from the predicted behavior of a natural comet. JUICE is the first observer, Jupiter Icy Moons Explorer, a spacecraft designed to study Jupiter's moons, Europa, Ganymede, and Callisto. It launched in 2023 and is currently on a complex trajectory that involves multiple flybys of Earth and Venus to build up the speed needed to reach Jupiter. On November 4th, 2025, it happens to be in the right place at the right time to observe 3Y Atlas just days after perihelion. This is not a planned mission objective. JUICE was not designed to study comets, but opportunity has presented itself, and ESA is taking it. JUICE carries cameras. Janus, a visible light imaging system, MAGIS, an infrared spectrometer, SVI, a sub-EM wave instrument capable of detecting gas composition. Together, these instruments can provide a comprehensive look at 3 Atlas in its post-Perihelion state. If the comet fragmented, Janus will see the debris field. If the chemical composition changed, MAGIS will detect it. If new gases are being released, SSWI will identify them. And because JUICE is not observing from Earth, because it has a different vantage point in space, it can see details that Earth-based telescopes might miss. The timing is critical. JUICE observes less than a week after perihelion. Whatever happened during that hidden window, thermal effects will still be evident. If 3I8 Adlays underwent massive outgassing, the coma will be expanded and bright. If structures were released, they will not have had time to separate significantly. If the trajectory changed, the deviation will be measurable. JUICE is positioned to catch 3 white atlas in the immediate aftermath before the evidence fades or disperses. But there is a catch. JUICE data will not be available immediately. The spacecraft is currently far from Earth on the opposite side of the Sun. It is using its medium-gain antenna to communicate because the main high-gain antenna is being used as a heat shield against solar radiation. Data transmission rates are slow, very slow, and the distance means signal travel time is significant. ESA has stated that they do not expect to receive JUICE's observations of 3 Atlas until February 2026, 3 months after the observations are made. 3 months of waiting to see what JUICE saw. That delay is frustrating but understandable. Deep space communication is constrained by power, bandwidth, and geometry. JUICE has limited resources. It is prioritizing its primary mission data. Squeezing in a bonus observation of an interstellar comet is scientifically valuable, but not the reason the mission exists. So the 3I8 data gets queued. It gets transmitted when bandwidth is available. It gets processed once it arrives, and by the time it is released publicly, we will already have months of Earth-based observations to compare it against. Those Earth-based observations start in mid-November. 3 Alpha Atlas will emerge from the sun's glare and become visible in the pre-dawn sky. Initially faint, initially low on the horizon, but brightening as it approaches Earth and as the viewing geometry improves. By late November, when the IWN campaign officially begins, the comet will be accessible to professional observatories with large telescopes and sensitive instruments. And by December, it will be bright enough that amateur astronomers with 8In or larger telescopes can track it. This is where the distributed observation network becomes powerful. NASA and ESA control the data from spacecraft and major observatories. They decide when to release images, when to publish findings, how to frame the narrative. But amateur astronomers are independent. They post their observations online within hours. They share raw images like curves, spectroscopic data. They collaborate across continents, comparing notes, identifying patterns. If 3I8 does something unusual in December, if it brightens unexpectedly, if secondary objects appear, if the trajectory deviates, amateur observers will document it, and that documentation will be public before any official statement is made. The IWN campaign is explicitly designed to coordinate this effort by requiring workshop attendance and closed registration. They ensure that participating observers understand the protocols. They're collecting standardized data. They're measuring astrometry with high precision. They're looking for exactly the kinds of deviations that would indicate non-gravitational forces, outgassing, fragmentation, trajectory changes. The campaign is surveillance, comprehensive, systematic global surveillance of an object that may or may not be what it appears. December 19th is the culmination, closest approach to Earth. At that distance, 269 million kilometers 3Y Atlas will not be visible to the naked eye, but it will be accessible to modest telescopes. And on that day, the comet will be at its brightest as seen from Earth, assuming it follows the predicted light curve. If the brightness is higher than expected, it suggests more surface area, more outgassing, or possibly fragmentation. If it is lower, it suggests the object is less active than models predict, possibly because it is not entirely ice, possibly because it is more dense, more solid, more structured than a typical comet nucleus. The closest approach also provides the best opportunity for parallax measurements. Observatories spread across Earth can measure the comet's position simultaneously. The slight differences in observed position caused by viewing from different locations on Earth allow precise calculation of distance and velocity. Any discrepancy between the predicted position and the measured position would indicate that the orbit has changed, that something happened during perihelion, that 3 for Atlas is not following a purely gravitational path. And then there is the fragmentation question. The mothership hypothesis, the idea that 3 for Atlas could release smaller objects during perihelion, objects that would follow slightly different trajectories. If that happened, we would start seeing secondary objects in November and December. Not debris, not random chunks of ice, discrete objects with their own orbits. The tidal forces from the sun would have separated them enough by December that they would be distinguishable. Observers would report multiple targets near the predicted position of 3 for Atlas. Each target would need to be tracked independently. Each would have a slightly different velocity and trajectory. And if the separations are too organized, if the objects are too evenly spaced or too similar in size, natural fragmentation becomes harder to argue. Lowe described this scenario as 3Y Adelus, resembling a dandelion flower which spreads its genetic information through numerous seeds, a biological metaphor for technological reproduction. The idea that an interstellar probe might carry smaller probes, many explorers, each designed to investigate a different target. Release them during perihelion when solar energy is maximum. Let them disperse. Let them fulfill their individual missions. It is speculative, but it is testable. If we see multiple objects, if they behave independently, if they target different planets or regions of the solar system, the hypothesis gains weight. The counter-argument is that comets fragment all the time. It is a natural process. Thermal stress causes cracks, cracks propagate, the nucleus splits. We've observed it with solar system comets. Shoemaker-Levy 9 fragmented into 21 pieces before hitting Jupiter. Other comets have disintegrated entirely. So if 38 fragments, it does not necessarily mean anything unusual unless the fragments behave unusually, unless they show evidence of propulsion or maneuvering, unless they maintain formations that defy simple ballistic mechanics. December also brings the whistleblower's prediction to the test. Many home-based observers will see it all. That was the claim. And in December, when 3 Atlas is accessible to amateur telescopes, when thousands of people are pointing their equipment at the sky, when images and data are being shared in real time across social media, we will find out. If there is something to see, the amateur community will document it. If there is nothing unusual, if 3 Atlas behaves exactly as a comet should, the whistleblower will be discredited. The prediction is binary. There is no middle ground. Either the amateur observers see anomalies, or they do not. There is also the gamma ray question. If the alleged Fermi detection was real, if 3 Atlas is emitting high-energy photons, that emission should continue or even intensify as the comet moves through its most active phase. Fermi data is public. Researchers can analyze the light curves for November and December. If there is a persistent gamma-ray source coincident with 3I Atlas's position that is verifiable, it becomes part of the official record. It shifts the entire discussion because natural comets do not produce gamma rays. And if 3 ITALS does, we need a mechanism. We need an explanation that does not require invoking artificial power sources. And so far, no such explanation has been proposed in the peer-reviewed literature. The November to December window is also when the CME impact effects would be most visible. If the solar ejection that Stephen Burns documented on October 21st reached 3 Fur Atlas and caused significant changes, those changes would manifest as brightness fluctuations, spectral anomalies, or structural deformations. CME impacts on comets can cause tail disconnection events where the entire ion tail is stripped away and a new one forms. They can cause sudden brightening as compressed coma gases floors more intensely. They can reveal internal structure if the impact pressure is strong enough to excavate material from beneath the surface. All of those effects would be observable in November and December. And if they correlate with Burns's predictions, his electromagnetic interaction model gains credibility. The IAWN campaign runs through January 27th. That gives 2 full months of coordinated observation after closest approach. 2 months to watch for late fragmentation, for trajectory adjustments, for any delayed response to perihelion passage. Some cometry processes are not immediate. Outgassing can continue for weeks after peak solar heating. Structural weaknesses can take time to propagate into full fragmentation. By extending the campaign into late January, IAWN ensures that even delayed anomalies will be captured. And then comes the closeout telecon. That is when the campaign participants convene to discuss findings, compare data, and compile results. That is when the professional astronomical community will have its first comprehensive look at what 3UALS did during its closest approach. The discussion will be technical astrometric precision, phototrick consistency, spectral analysis. But the underlying question will be simple. Did anything unusual happen? And if the answer is yes, if there are confirmed deviations or anomalies that cannot be explained by standard commentary models, the closeout telecon becomes the moment when the scientific community officially acknowledges that 3 is more than just another interstellar comet. The public will not have to wait for February. December observations will be shared as they happen. Online forums, social media, astronomy groups, all will be buzzing with reports and images. The real-time documentation of 3i Atlas by a global network of independent observers will provide a level of transparency that no space agency can control. That distributed verification is both a strength and a challenge. A strength because it prevents data suppression or selective reporting. A challenge because it means rumors and misinterpretations can spread as quickly as legitimate findings. November and December will answer questions that have been building since July. Is 3 Atlas a natural comet with unusual but explicable properties, or is it something that requires us to expand our understanding of what is possible? Did anything happen during the hidden perihelion passage? Did the trajectory change? Did objects separate? Did the emissions intensify in ways that suggest more than ice sublimation? We will have data, lots of data, more data than we have ever collected on an interstellar object. And from that data, patterns will emerge. Patterns that either confirm the anomalies are just statistical flukes and observational artifacts, or patterns that suggest we are witnessing something unprecedented, something that changes our place in the universe, something that means we are not alone and we never were. The dark forest hypothesis. There is a question that has haunted humanity since we first looked up at the stars and understood what they were. Where is everyone? Enrico Fermi posed this question over lunch in 1950, and it has become one of the most profound paradoxes in science. The Fermi paradox. If the universe is so vast, so old, filled with billions of galaxies, each containing billions of stars, many of which have planets in the habitable zone, then where are all the aliens? Why have we not detected any signals? Why have we not found any evidence of advanced civilizations? Why does the cosmos seem so silent, so empty, so devoid of intelligence other than our own? There are many proposed solutions to this paradox. Maybe intelligent life is extremely rare. Maybe civilizations destroy themselves before they can spread to the stars. Maybe they are out there, but communication across interstellar distances is simply too difficult. Maybe we are looking in the wrong places or listening at the wrong frequencies. But there is another explanation, darker and more disturbing, that has gained traction in recent years. The dark forest hypothesis. The name comes from a science fiction novel by Ludwig in the Dark Forest published in 2008. In the story, the universe is compared to a dark forest at night. Every civilization is a hunter moving silently through the trees. You cannot see the other hunters. You cannot know their intentions. And the forest is full of predators. The safest strategy is to stay hidden. Stay silent, because the moment you reveal your position, you become a target. Any civilization that broadcasts its presence risks annihilation from more advanced species that view newcomers as potential threats to their survival. It is a chilling idea. The universe is not empty because life is rare. It is silent because making noise is suicidal. Civilizations that announce themselves get wiped out. The ones that survive are the ones that master stealth, that hide their technological signatures, that move through the cosmos like ghosts. And if this hypothesis is correct, then humanity has made a terrible mistake. We have been broadcasting radio signals into space for over a century. We have sent messages to nearby star systems. We've announced our presence to anyone listening, and if the dark forest is real, we may have just painted a target on our planet. Now, how does this relate to 3i Atlas? Harvard astrophysicist Avi Loeb and his colleagues published a paper exploring this exact question. The paper is titled "Is the Interstellar Object 3 Wireless Alien Technology?" and it examines the possibility that this object could be a probe sent by an advanced civilization, not necessarily for peaceful exploration. The paper explicitly considers the dark forest scenario. What if 3Y Atlas is a hostile reconnaissance mission? What if it is here to assess whether Earth poses a threat? What if its trajectory, its timing, its properties are all deliberate? The paper emphasizes that this is largely a pedagogical exercise, a thought experiment. The authors do not necessarily believe 3I Atlas is alien technology, but they argue it is worth analyzing the possibility, because the consequences, if true, could be dire for humanity, and the data we've collected so far does not definitively rule out an artificial origin. So let us walk through their reasoning. Let us consider what it would mean if 3I Atlas is not a comet. First, the trajectory. 3I Atlas is traveling within 5 degrees of the ecliptic plane, that is the imaginary disk that contains the orbits of the planets around the Sun. Most interstellar objects should arrive from random directions. Space is three-dimensional. Objects ejected from other star systems should approach from all angles. Yet, 3 Atlas arrives almost perfectly aligned with the plane of our solar system. The statistical probability of this alignment is less than 1%. It is not impossible, but it is suspicious. 1 Oumuamua, the first interstellar visitor, had an inclination of 123 degrees. 2 Aboris had an inclination of 44 degrees. Both arrived at steep angles relative to the ecliptic. 3 Atlas is different. It comes in low and flat, like something designed to survey the planets, like something that wants to get close to multiple worlds during a single pass through the system, and its trajectory does exactly that. 3 Atlas passes near Mars, Venus, and Jupiter, not just near in astronomical terms, but close enough for detailed observation. Close enough that if this were a spacecraft with sensors, it could collect high-resolution data on the atmospheres, surfaces, and electromagnetic signatures of 3 major planets. That is not proof of artificiality, but it is the kind of trajectory you would choose if you were designing a grand tour mission through an alien solar system. The timing is also interesting. 3. I Atlas reaches perihelion on October 29, 2025. According to Lowe's calculations, if you trace the object path backward through the galaxy, it would have entered the outer boundaries of the solar system approximately 8,000 years ago. 8,000 years. That is roughly when human civilization began. When we transitioned from hunter-gatherer societies to agriculture, writing, cities, and organized technology. When we started leaving permanent marks on the planet that could be detected from space. Is that a coincidence? Maybe. The universe does not care about human timelines. But if you were an advanced civilization monitoring nearby star systems for signs of emerging intelligence, 8,000 years would give you plenty of time to dispatch a probe and have it arrive just as that civilization reaches a critical threshold, just as it develops the technology to detect and potentially intercept your probe, just as it becomes interesting. Now, let us talk about the O-Birth maneuver again, because this is central to the dark forest scenario. 3I Atlas reaches solar conjunction on October 21st and perihelion on October 29th. During this window, it is hidden from Earth-based observation. It is moving at maximum velocity, and it is at the optimal point to execute a trajectory change using minimal energy. If this object wanted to slow down and enter a bound orbit around the Sun, this would be the moment to do it. A relatively small thrust applied at perihelion could reduce its velocity enough to trap it in the solar system instead of sending it back into interstellar space. Why would it want to stay? If 3S is a reconnaissance probe, its mission might not be complete. Maybe it needs more time to observe. Maybe it is waiting to see how humanity reacts to its presence. Maybe it is transmitting data back to its origin point and awaiting further instructions. Or maybe in the darkest version of this scenario, it is preparing for the next phase of its mission. Deployment of secondary probes, activation of systems that have been dormant during the long interstellar journey, actions that require being in a stable orbit rather than on a hyperbolic escape trajectory. The paper explores what would happen if 3 performed a reverse O-Earth maneuver. Instead of speeding up, it slows down. The calculations show that if the object applied a non-gravitational acceleration of approximately 5.9, 10, 5 astronomical units per day squared, normalized at 1 astronomical unit from the Sun, it could alter its trajectory to intercept Earth. Not immediately, but in late November or early December of this year, right around the time the IWN observation campaign is supposed to provide clarity on the object's behavior. That is a testable prediction. If 3IA Atalis changes its orbit during perihelion, we will detect it in November when the object becomes observable again. Its position will not match the purely gravitational trajectory. Its velocity will be different, and if those changes point toward an Earth intercept, we will have confirmation that this object is under intelligent control. We will also have very little time to respond. The paper does not stop there. It also considers a Jupiter intercept scenario. 3E Atlas is scheduled to pass within 54 million kilometers of Jupiter on March 16, 2026. If the object wanted to use Jupiter for a gravitational assist for a slingshot maneuver that could send it toward the inner solar system or even out of the system at higher speed, that flyby would be the perfect opportunity. And the non-gravitational acceleration required to target Jupiter is within the range of what could be produced by outgassing from a comet, which means if we detect such an acceleration, it would be ambiguous. We would not know if it is natural or deliberate. This is the nightmare scenario of the dark forest hypothesis. An object that looks mostly natural, that has plausible deniability built into its design, that can maneuver in ways that mimic cometary activity, making it impossible to definitively prove artificiality until it is too late. A probe that gathers data, transmits it home, and then either leaves quietly or activates a secondary mission depending on what it has learned about us. Now, to be absolutely clear, Lowe and his colleagues emphasize that the most likely outcome is that 3 Atlas is a completely natural interstellar comet. They're not claiming it is alien technology. They're not saying we should panic. They're saying we should consider the possibility, analyze the data with that hypothesis in mind, and prepare for contingencies. Because if we are wrong, if we dismiss the artificiality hypothesis out of hand, and it turns out to be correct, the consequences could be catastrophic. But let us also consider the counter-argument. Why would an advanced civilization that mastered interstellar travel use such a primitive approach? Why send a slow probe that takes thousands of years to reach its target when you could send something faster, stealthier, more capable? Why risk detection by passing so close to planets? Why make your trajectory so obviously interesting that it triggers speculation and analysis? One answer is resources. Interstellar travel is expensive. Even for an advanced civilization, accelerating a probe to high fractions of light speed requires enormous energy. Maybe this is the most economical approach. Send relatively slow probes to many star systems, let them drift for millennia, and gather data on civilizations as they develop. By the time the probe arrives, you get a snapshot of that civilization at a particular stage of advancement. If humans had launched a probe to Alpha Centauri in the year 0, it would be arriving there right now, and whatever it found would reflect 20 centuries of technological and social evolution. Another answer is stealth through camouflage. If you want to study a civilization without alarming it, you disguise your probe as a natural object. You give it a commentary coma. You make it outgas. You design it to look at first glance like an ordinary visitor from interstellar space. Only careful analysis would reveal the anomalies, and by the time anyone figured it out, the probe would have completed its mission and moved on. This is actually not science fiction. We do this ourselves. Biomimetic drones designed to look like birds. Surveillance devices disguised as rocks or trees. The principle is sound. If you want to observe without being observed, you mimic the environment. And in space, that means looking like a comet or asteroid, especially if your target civilization is not yet advanced enough to mount an interception mission. Which brings us to another uncomfortable truth. Even if we confirm tomorrow that 3I Atlas is artificial, what could we do about it? Launch a spacecraft to intercept. The object is moving at over 200,000 km per hour. It will take decades to develop propulsion systems capable of catching up to it. By the time we could reach it, the mission would be over. It would have observed what it needed to observe, transmitted its findings, and moved on to the next target. We are not capable of intercepting interstellar visitors, not yet. which means if there are probes studying us right now, we are essentially powerless to stop them. That realization should be sobering. We are not the hunters in the dark forest. We are the prey, or at least the subjects of study. And if the dark forest hypothesis is correct, if the universe is full of civilizations watching each other, assessing threats, deciding who lives and who gets eliminated, then we are already on someone's radar. We've been broadcasting our presence for a century. We have built technology that produces detectable signatures across the electromagnetic spectrum. We are loud, obvious, and vulnerable. And 3, iAtlas might be the first confirmation that someone is paying attention. Lowe's paper ends with a call for more data, more observations, more analysis, because the only way to resolve this question is through science, through rigorous measurement and testing of hypotheses. If 3I8LS behaves exactly like a natural comet, if it fragments at perihelion, the way many comets do, if its trajectory remains purely gravitational with no unexplained accelerations, then we can rule out the artificial hypothesis with confidence. But if it does something unexpected, if the data shows anomalies that cannot be explained by natural processes, then we need to be prepared for the possibility that we are not alone, and that whoever sent this probe may not have our best interests at heart. The dark forest hypothesis is terrifying because it reframes the search for extraterrestrial intelligence. We have spent decades listening for signals, hoping to make contact, assuming that any civilization capable of interstellar communication would be benevolent or at least neutral. But what if contact is the last thing we should want? What if the silence of the cosmos is not absence but caution? What if every advanced civilization has learned the hard way that broadcasting your location is a death sentence? If that is true, then 3Gatlas might not be a probe sent to make friends. It might be an assessment, civilization checking to see if we pose a threat, and depending on what it reports back, we might find out what happens to species that get too loud, too visible, too interesting. We might learn why the dark forest is so quiet. Not because it is empty, but because everything that made noise is already gone. This is speculation. This is the extreme edge of the hypothesis space, but it is grounded in logic, in game theory, in the cold calculus of survival in a potentially hostile universe. And it is worth considering because the consequences of ignoring it, if it turns out to be true, are existential. 3Atlas might be just a comet or it might be a test. A final exam we did not know we were taking. And the gray determines whether humanity survives or joins the countless other civilizations that failed to stay quiet in the dark forest. We will know soon enough. The observation window opens in November. The data will come in, and we will see if this object follows the expected trajectory or if it does something that forces us to confront the possibility that we're being watched, that we've always been watched, and that our survival depends on what the watchers decide about us. The truth. In 60 days, we are at a crossroads, not just in the story of thrift to Atlas, but in how we understand our place in the universe. Everything we've discussed over the past 2 hours, all the anomalies, all the speculation, all the theories, both mundane and extraordinary, they all converge on a single moment in time. December 19th, 2025. The day 3Atlas makes its closest approach to Earth. The day when thousands of amateur astronomers and professional observatories will have their telescopes pointed at the same patch of sky. The day when the data becomes undeniable, whatever that data shows. 60 days from now, we will know. Not with absolute certainty, perhaps. Science rarely offers that kind of closure, but we will have enough information to make informed judgments. We will see if the trajectory remained purely gravitational or if something changed during that hidden perihelion passage. We will see if the object fragments like a natural comet or maintains structural integrity. We will see if there are any unexpected emissions, any secondary objects, any behaviors that cannot be explained through conventional physics. And most importantly, we will see if the pattern of silence from space agencies continues, or if they're finally forced to share what they have known all along. Let us walk through the timeline one more time, because understanding what happens when is crucial to interpreting the data. Today is October 22nd. 3Atlas is currently behind the sun from Earth's perspective. It is in solar conjunction, invisible to our telescopes, racing toward perihelion at speeds exceeding 68 km/s. In 7 days on October 29th, it reaches that closest point to the Sun, 200 to 3 million kilometers, just inside the orbit of Mars. This is the moment of maximum solar heating, maximum outgassing if it is a comet, and maximum opportunity for any propulsive maneuver if it is not. For the next few weeks, 3I-8 Atlas remains too close to the Sun's glare for observation from Earth. But on November 4th, something interesting happens. The European Space A's JUICE spacecraft, Jupiter Icy Moons Explorer, passes within 64 million kilometers of the object. JUICE is equipped with cameras, spectrometers, and particle sensors. It is designed to study the icy moons of Jupiter, but it can be retasked for a brief observation window, and ESA has confirmed that JUICE will attempt to observe 3 Flight Atlas during this flyby. This will be our first post-perihelion look at the object. Our first chance to see if anything changed, if the coma has expanded or contracted, if there are new jets of material, if the spectral signature has shifted, if there are any fragments or secondary bodies trailing behind the main nucleus. JUICE is far enough from the Sun that its instruments will have a clear view. And because the spacecraft approaches from a different angle than Earth-based telescopes, it might reveal features or asymmetries that were not visible before. But here's the catch. JUICE is currently close to the Sun using its high-gain antenna as a heat shield. It is communicating with Earth through a smaller medium-gain antenna at much lower data rates, and it is on the far side of the Sun from Earth, which limits communication windows. ESA has stated that they do not expect to receive the JUICE observation data until February 2026, 4 months after the flyby, 4 months of waiting to see what one of our most capable spacecraft observed during its close pass. That delay is both frustrating and suspicious. If JUICE captures something extraordinary, something that changes our understanding of 3 Atlas, we will not know about it for months. And by the time the data is released, the object will have already made its closest approach to Earth, already passed Jupiter, already moved beyond the point where interception or further study is feasible. The information will be historical, interesting, but no longer actionable, unless of course the data is analyzed in real time by mission controllers and appropriate decisions are made behind closed doors without public disclosure. While we wait for JUICE data, 3 Atlas continues its journey. By late November, it emerges from the Sun's glare and becomes visible to Earth-based telescopes again. This is when the IWN observation campaign officially begins. November 27th, workshops have been held, participants have been vetted, protocols have been established, and now every night for the next 2 months, coordinated observations will track the object as it moves through the constellation Virgo, low in the pre-dawn sky. This is when amateur astronomers get their chance. 3I Atlas will reach an estimated magnitude of 12 to 13. Too faint for the naked eye, too faint for binoculars, but within reach of an 8-in telescope in dark skies. And there are thousands of amateur astronomers around the world with equipment capable of imaging it. People who are not bound by institutional protocols or data embargoes. People who will post their observations online within hours of taking them. People who will compare notes, analyze trajectories, and spot anomalies that official channels might prefer to keep quiet. This is the democratization of discovery. The moment when the truth, whatever it is, becomes impossible to suppress because you cannot control data that belongs to everyone. You cannot embargo observations made by independent researchers who owe nothing to NASA or ESA or any government agency. The whistleblower predicted this. They said December will reveal everything to home-based observers, and they are right, not because the object will necessarily do anything dramatic, but because the sheer number of people watching ensures that any deviation from expected behavior will be documented, shared, and debated before official statements can shape the narrative. December 19th is the key date, closest approach, 1.88 astronomical units from Earth, 269 million kilometers, still more than 700 times the distance to the Moon, still too far for any immediate threat, but close enough for high-resolution spectroscopy, close enough to resolve the nucleus from the coma if the object is large, close enough to detect any unusual emissions or secondary objects that might be trailing along. And here is what we should be looking for. First, the trajectory. Has it deviated from the purely gravitational path predicted by the orbital elements calculated in July? Even a tiny change, a fraction of a degree, would indicate non-gravitational forces at work. That could be cometary outgassing, or it could be something else. Second, the spectral signature. Does the object still show that bizarre nickel without iron emission? Does the ratio of carbon dioxide to water remain anomalously high? Do any new chemical species appear that were not detected before? Third, the morphology. And what does the coma look like? Is it symmetric or lopsided? Are there jets pointing in specific directions? Is the nucleus still hidden by dust, or has it become visible? And fourth, any companions? Has the object fragmented? Are there smaller pieces following the same trajectory? Or in the more speculative scenario, are there secondary objects moving independently? If 3I8LS behaves like a natural comet, we should see fragmentation. Comets often break apart when they get close to the sun. The thermal stress, the outgassing, the tidal forces all work together to crack the nucleus, especially for an object that has been wandering interstellar space for potentially billions of years. The ice and rock would be pristine, never heated, never stressed. The first pass close to a star could be devastating. We should see pieces. We should see a debris trail. We should see the object slowly disintegrating as it moves away from the sun. If that happens, the comet hypothesis is confirmed. 3 Atlas is natural. All the anomalies have mundane explanations. The nickel emissions are just unusual chemistry. The trajectory is just statistically unlikely, but not impossible. The activation of IWN was precautionary, and we can all relax and appreciate this rare opportunity to study an interstellar visitor up close. But if it does not fragment, if the object maintains structural integrity, if it passes perihelion without breaking apart, that is anomalous. Most comets do not survive close passes intact, especially not interstellar comets that have never been heated before. And if 3 Atlas not only survives but shows no signs of significant outgassing, no debris trail, no chunks falling away, that raises serious questions about what it is made of, about whether it is held together by something other than gravity and ice, about whether its structure is artificial. Then there is the Jupiter flyby, March 16, 2026. 3. Why Atlas passes within 54 million kilometers of the gas giant. NASA's Juno spacecraft will be in position to observe. Juno has ultraviolet spectrographs, infrared mappers, microwave radiometers, and a suite of instruments designed to study Jupiter's atmosphere and magnetosphere. But they can be pointed at a comet. And at 54 million kilometers, Juno will have one of the closest views of 3Y Atlas we will ever get from a spacecraft. This is the final data point, the last chance for high-quality observations before the object leaves the inner solar system. If 3I is going to do something unexpected, if it is going to execute a maneuver or deploy secondary payloads or reveal its true nature, the Jupiter flyby is the logical moment. Far enough from the sun that solar interference is minimal, close enough to a massive planet that gravitational assists are possible, and positioned where NASA has assets that can document everything in detail. But again, there will be a delay. Juno data takes time to transmit, time to process, time to analyze. By the time we see what Juno observed, 3I will already be on its way out of the solar system, moving toward the outer planets and eventually back into interstellar space. The window for interaction will have closed. If there was something we should have done, some mission we should have launched, some response we should have coordinated, it will be too late. That is the frustrating reality of astronomy. We're always looking at the past. Light takes time to travel, data takes time to transmit, analysis takes time to complete. By the time we understand what we're seeing, the moment has passed. 3 Atlas is here now, moving through our solar system, and we're scrambling to gather data before it leaves. In a few years, it will be gone, a receding point of light growing fainter each day until even our most powerful telescopes cannot track it anymore. and we will be left with whatever information we manage to collect during this brief window. Unless it does not leave, unless the Earth maneuver happened, unless the object slowed down during perihelion and entered a bound orbit, then 3 Atlas would stay in the solar system. It would loop around the sun on a long elliptical path, coming back again in a few years or decades, depending on the new orbit, and we would have ongoing opportunities to study it, to send missions to intercept it, to figure out what it really is. That scenario has not been ruled out. We will not know until November when the object becomes visible again, and we can recalculate its orbit based on post-perihelion observations. If the velocity is lower than expected, if the trajectory has changed in ways that trap it near the sun, we will have confirmation that something happened during those hidden weeks behind the sun. Something that altered the object's fate, and we will have to confront what that means. There is one more possibility we should discuss: the consciousness shift theory. The viral videos and posts claiming that October 30th at 11:44 Universal Time will coincide with a global electromagnetic event that affects human consciousness. The math about human resonance amplification, the predictions about technology failures, and mass synchronization of billions of minds. This theory has captured imaginations, but it lacks scientific foundation. The mechanisms described do not align with how electromagnetic fields interact with biological systems, and the claims about observing changes in December are vague and untestable. But it speaks to something deeper, a yearning for meaning. A desire for this object to be more than just a comet, a hope that something extraordinary is happening, something that will change us, elevate us, connect us to the cosmos in ways we've never experienced. That longing is human, it is understandable, but it should not blind us to the actual data, to the real science being done by real telescopes, gathering real information that will either support or refute these extraordinary claims. If 3I8LS does affect Earth in some way, it will be measurable. It will show up in instruments. It will be documented by magnetometers, radio telescopes, particle detectors, and all the other sensors we use to monitor the space environment. We will not need to rely on subjective experiences or anecdotal reports. The data will tell us what happened, and if the data shows nothing unusual, then the consciousness shift theory joins the long list of apocalyptic predictions that failed to materialize. So where does that leave us? We have an object with multiple confirmed anomalies. We have space agencies that have activated planetary defense protocols while maintaining public silence on key data. We have a whistleblower claiming evidence of artificial signals. We have scientific papers exploring the possibility of extraterrestrial technology. And we have a countdown to a series of observations that will either confirm this is all a natural phenomenon or force us to reconsider everything we thought we knew about our place in the universe. 60 days. That is the window. By mid-December, we will have enough data to make informed conclusions. The IWN campaign will be underway. Thousands of observations will have been logged. The trajectory will be recalculated with high precision. The spectral signatures will be analyzed, the morphology will be documented, and we will see if this object follows the script for a natural comet or if it writes its own story. I want to be clear about what I think is most likely. The simplest explanation is usually correct. 3 Atlas is probably a comet, a large, unusual, scientifically fascinating comet from another star system. The anomalies probably have natural explanations that will become clear as we gather more data. The activation of IAWN is probably precautionary, a way to test coordination protocols on a real target. The whistleblower is probably someone with partial information or someone fabricating claims for attention, and December will probably be anticlimactic with the object behaving exactly as a comet should, but probably is not certainty. And the data we have now leaves room for doubt, leaves room for other possibilities. And that is why we watch, why we wait, why we keep our telescopes pointed at this visitor and document everything it does. Because if the unlikely turns out to be true, if 3I8LS is something other than natural, we want to know. We need to know, and we will know soon. December 19th, mark it on your calendar. Search for 3I8LS in the morning sky if you have the equipment. Follow the discussions online as observations come in from around the world. Watch to see if NASA or ESA finally break their silence and release the data they have been withholding. And consider what it would mean if this object, this interstellar visitor that appeared in our sky with perfect timing and impossible alignment, turns out to be our first confirmed encounter with technology from beyond Earth. The truth is out there, literally moving through space at 210,000 km/h. And in 60 days, we will have our answer. Not the final answer, perhaps, not absolute proof, but enough information to know whether we are alone or whether something from the dark forest has come to see what all our noise is about. Whether we pass the test or whether we are about to learn why the cosmos is so quiet. With a 3 atlas is a comet or a message, and what that message means for the future of humanity. The countdown has started, the telescopes are ready, the observers are prepared, and somewhere behind the sun, hidden from view, 3 atlas continues its journey toward the moment when all eyes will be watching and all secrets will be revealed.